Hi, so I was introduced, my name is Migas, and I work as a front-end developer and designer, and I have the title of Google Developer Expert in the area of web technologies. The title of the talk is Fast but Not Furious Debugging User Interaction Performance Issues. So during past few years, I've had a chance to develop and maintain free open source libraries, all connected to animations. And during that time, I really put a lot of effort into getting to know how to optimize the performance, how to make these libraries the best they could be, performance and accessible. And during that time, I did a lot of reading on performance, and I saw that there was one term emerging really fast. And then this term is perceived performance. While there is not one definition of perceived performance in regards to web technologies, it boils down usually to two things. The first, meaningful paint, which is a metric that tells us how long will it take for the website to be painted to the user, like first meaningful content to be painted to the user, and then time to interactive, which is a metric that tells us how long will it take for the user to start interacting with the loaded content. And if you search some more for articles on perceived performance, you would find things like how to optimize the critical rendering path, which is how to take a part of our code that is responsible for what's visible above the folds and just extract it. Or how to use progress bars instead of spinners because they make user think that something is loading faster. Or even how to have placeholder content like Facebook does, where we have these gray areas on the page that mark the places where the content will be any second. Or even how to start uploading content before the user even knows they want to upload the content. They've only chosen the, for example, image in their media library on their device. So for me, I'm not really sure if I agree that this is what we should call perceived performance. Because all these metrics are actually more a bit about like faking, loading things fast, or actually loading things fast. So I think this is what we should rather call perceived load performance. And for me, these metrics are like caring about getting content fast for the user, like getting to the top of the mountain really fast and nicely, but then leaving user to themselves. And I think that we should strive rather for real perceived performance, where the user is happy on the road and also when the page is loaded. So this means that I think that perceived performance is not only about first meaningful paint and time to interactive, but also about having our page smooth at all times. And this is something we're going to talk about today, how to achieve it. So the agenda is, we'll talk about why sometimes interactions feel slow, about browser rendering and frames, about types of trigger changes in the UI, about how to test for interaction performance, and about some potentially dangerous UI patterns you might have in your app. So why sometimes interactions feel slow? The reason usually is junk. Junk can be described as lack of smoothness, stuttering. So once you see it, you'll see it always in the apps and over the web. So junk happens when the browser refresh rate doesn't hit the refresh rate of our device. So most customer market devices have a refresh rate of 60 frames per second. This means that we have 1,000 milliseconds. This is 1 second. We divide it by 60, and this means that we have 16 milliseconds. This is how much time browser has to render each frame. But there are some devices rolling to the consumer market that have 120 frames per second refresh rate, namely the new iPads Pro and Razer gaming smartphones. This means that for these devices, we would have 8 milliseconds to render each frame. This is really not much time. We already are struggling to actually get this 16 frames per second deadline. And I'm not saying that there might be some revolution, but if you remember what happened when Retina screens started rolling to the market, we started supporting higher pixel density pictures on the web. So maybe at some point we'll have to start developing our animations and interactions to support also 120 frames per second devices. And this is something that in gaming industry is already a standard, like developing code so that it would offload the device a bit. So like working in between the frames and making it easier for the device to render. And this is something that we as web developers don't yet know how to do. So how can we help the browser to make it on time? How can we help the browser to actually start offloading the device? There are two things we can do. We can either use web workers for some heavy tasks. I'm not going to talk about web workers because it's not a JS day, but you can look what they do later. Basically, you can take any like heavy JavaScript calculations and put it into the background thread and offload a main thread a bit. Or you can optimize the main thread. And this is something we're going to try to achieve today. So the bottom line is, if we interact with the page, the browser needs to start rendering the frames, be it 60 or 120 frames per second. But what the frame consists of? We have a few steps. They're all in sequence. So we have JavaScript or events. We have recalculation of styles, layout, paint, and then compositing of the layers. And they all need to happen one after another. If we have, for example, paint, you can't have paint before JavaScript. We would have to re-render the frame. So this doesn't really tell us much yet. So what does browser do during these steps? So first, the change happens and then event is fired. It doesn't have to be JavaScript change. It can be, for example, scrolling or hovering or clicking on some element that will render a pop-up, any interaction basically. Then the browser needs to recalculate the styles accordingly to what just happened. After that, we will have the layout recalculation. During that step, the browser is trying to figure out how much space each element is going to take and where it's going to be positioned. And it's rendered as a collection of vector boxes. After we have our layout, everything gets rasterized and it's painted to the layers. So we take our vector boxes and we basically put them into pixels. What's happening there? The browser is painting all of these things into layers. You can think of layers as layers in Photoshop. If you have one thing on one layer and another thing on another layer, you can move them around and they don't affect each other. So this is something great to leverage, for example, for animations or interactions. But if you have two things on the same layer, then there's not much you can do. They're just glued together. And they actually can get in the way of each other. So by default, the browser will create only one layer for the whole website. But there are some things that will make the browser create more layers. So what creates new layers? 3D or perspective transforms. If we have animated 2D transforms or opacity, but they have to be animated to create layer. If we have element that is on the top or a child of already existing compositing layer, if we use accelerated CSS filters, in some special cases, the video, canvas, or plugins like Silverlight or Flash, because the browser knows that, okay, in this area, I'm going to have content that is going to be changed pretty fast and a lot, so I need to create another layer for that. And then there is one thing that lets us tell the browser explicitly, I want this area to be changed a lot, and I think this is going to be profitable for it to be on another layer, so you can add the will change CSS property. Using it is fairly simple. If you, for example, as here, want to have some interaction on hover, you should upfront tell the browser what property will be changed on hover. So we have will change transform, and then on hover we change transform property. But you should be careful because each layer consumes memory, so you should use them wisely. You won't probably experience that on your very good device that you're developing with, but there are some users who have some low-end phones, and for them, too many layers can actually make the browser crash. So it can be tough for them. So you need to find the right balance between the number of layers you want to have and the browser capabilities. And then the last step is compositing. This step happens always if you have more than one layer. And during that step, the browser is just taking all the layers and it's just gluing them together to create one frame, one image that is then shown to the user. This is the step that is happening on the GPU, not the CPU, so it's quite performant. It's taking some work of the CPU. So this is what a frame looks like, or what it can look like, actually. There are different types of frames depending on the type of change that you trigger. So there are 3 types of change. First type of change is layout change, also called the reflow. It happens when we change properties like width, height, margins, display, and properties like that. And at this point, the browser needs to go through all the steps because it needs to change the geometry of the page. It needs to recalculate the layout, go through the painting step, and all of this. It's a very heavy type of change, so you should really avoid animating these properties or just changing them during the interactions. Then there is a paint change. It happens when we change properties like background color or box shadow, colors or background. And at this point, the browser knows where everything is positioned, what size it has, so it doesn't need to go through the layout step. So this is a bit more performant type of change, but still, sometimes the paint step can be the most heavy part of the pipeline, so we should also avoid doing this type of change. And then last type of change is compositing change. It happens when we change properties like transform and opacity, and the browser doesn't have to go through layout and paint steps, so this is the most optimal type of change. Also, as I said, compositing happens always if we have more than one layer, so this is the type of change we should be going through if we want to do some animations or interactions. We should change transforms and opacity. So this is something you should remember. So, but this all kind of sounds hard to comprehend, right? How we can actually test if we have problem with reflows or repaints. Reflows can be quite obvious. If we have one element that is pushing other elements out of the view, if we have one element that is changing its size without us using a transform scale property, then probably we're experiencing the reflow. Unfortunately for repaints, it's not that easy. For example, in this example, I found out that the repaint doesn't happen only when we use the last star on the right, and it's because it's not overlapping the text. So it's something I would never be able to find out if it wasn't for the DevTools. And DevTools are, in general, the best way to check if we have any performance issues with our runtime performance. So first thing you should do is to go to the performance tab, both in Chrome or Firefox, and try recording the interactions that are happening on your website. Here you can see like this green bar, which tells you how long the frame is taking. So if it's taking way more than 16 frames per second, then you might take a look. If you click on it, it will show you all the steps that were happening during this frame. And if you see what is taking the longest, you can actually start figuring out how to fix that. Using it is quite straightforward. You need to go to the performance tab, hit this record button, and then start interacting with the page. The shorter the recording, the better, because it's going to be easier to debug. So this is, of course, in DevTools. Then there's a Layers tab in Chrome. This is amazing tool. It's a bit hidden. You need to go to this three dot menu on the right, click in there's More Tools and Layers tab, and it will show you all the stacking context of your page, so you can see all the layers, how they look. You can also see some layers that you don't want to see there, and if you click on each layer, it will show you the reason why it was created. So it's like really powerful tool. Unfortunately, it's also pretty heavy. So I, for example, had a trouble to record the video of that. So if your computer is not that powerful, you actually might want to turn to the rendering tab, which also shows us the layer borders. It's a bit less fancy, but it also can show you the paint flashing or FPS meter, which will show you how many frames per second your application is running, or some scrolling performance issues. And if you enable that, it will look like that. You have these green areas are what gets repainted when you scroll through Facebook, for example. And then you see how many frames per second the app is running on. Also, you might want to test also separately paint flashing in Firefox by toggling in settings, toggle paint flashing, because sometimes things that would trigger repaints in Firefox won't trigger repaints in Chrome. So this is something you might want to remember. And then last but not least is a performance monitor tab in Chrome. What you need to do here is just open this tab, start interacting with the page. It tells you things like CPU usage, if you have any reflows, if you have any repaints. And for example, for the performance page, it would be around a few % of CPU usage, no reflows, hardly any repaints. For the page that was not really performing well, that I was testing, it was around 70 or 80% of CPU usage, a lot of reflows, a lot of repaints. So this is like easy test to see if your page is in general performant. But this is a lot of things to test, and if your page is like really complex, then it might be quite overwhelming. Like, wait, where do I start? Do I test every part of the page? Fortunately, there are some potentially dangerous UI patterns that almost always can cause problems. So if you start with taking care of them, probably your page will start performing better easily. So what are these potentially dangerous UI patterns? First of all, there are animations. If you have an animation that is not really optimized, the user will always see it. So what you can do about it? Well, my first advice is to not overuse animations. So if you have animation, if your animations are not guiding user through the website, if they're not helping them to understand what just happened, and they're like only for decoration, I would rather skip them. You should also animate only transform and opacity if it's possible, for the reasons I said at the compositing type of change. If you want to support now this 120 frames per second devices with your animations, you shouldn't use request animation frame because some browsers are capped at 60 frames per second, like mobile Safari, so it will never reach 120 frames per second. If you want to support these devices, you should rather use CSS animations or web animation API. Otherwise, request animation frame is great. So I'm not saying to not use it at all. Also, you shouldn't animate elements that are below other elements, like fixed nodes, for example, because there's going to be some layer creation that you might not want. And also, even if your animation is like super optimized, if you apply it to 100 elements, it's not going to be performing really well. So if you're thinking about having some animation of falling snow on your page for Christmas, then you might want to do it a bit more optimal than having 100 divs or 1,000 divs on a page. Then there is a parallax effect. So I was trying to look for the parallax effect that would be optimized, and this is what I found. To be fair, it's not the worst. It's really kind of good for parallax. But still, what you can see here, these green areas are like full page repaints. This is a paint storm. So paint storm happens when the whole browser window needs to get repainted with each frame. You can imagine it's not very performant. So for a parallax effect, it's almost always bad and it causes paint storms. You shouldn't use scroll events for that, and you shouldn't use the background position because these are both techniques that would cause the paint storms. If you really need parallax effect on your page, you might want to use 3D transforms in perspective technique. And the link is here and the slides will be shared later. Fixed elements. Almost every website now has fixed elements from what I've seen. The problem is, as you can see with GitHub sign here, they get repeated on scrolling with every frame as well. Fortunately, there is pretty easy fix. You might want to use will change or transform translate 3D, which will also create a layer to avoid repainting. What will happen then? We will have this, our whole website on one layer, and then the fixed element on another layer, and they're not going to be affecting each other. So this is good. Scrolling events. It's a bit more JavaScript-y thing than CSS-y, but I guess you can cope with that today. So scrolling events are not really performance usually. And we rather should avoid attaching the scrolling events to the whole browser window, to the whole document. If it's possible, we should rather try to have some smaller areas instead. We can also take advantage of passive event listeners, of course use them with polyfill feature detection. And you can just put them, like pass them as a flag to your event listener. And what will happen is, if you have the event listener that is scroll or touch based, the browser is anticipating that at any second you might call prevent default, which will stop the scrolling or this touch event. And this is a bit overhead work for the browser to anticipate this. And if you pass the flag of passive true, the browser will know that it's safe to just skip this step because you'll never call prevent default from this function. So this is something you can take leverage of. Then hover effects. I don't remember any page in the recent years without hover effects, and in general they're not very harmful unless there are too many, or if the areas where you can hit this hover areas are too big. So like here, if you scroll, for example, Facebook in Firefox, sometimes it can be really laggy because the areas that you can hit with your mouse are pretty big. So what you can do, if you are sure that they will happen often and the user is bound to hover over these elements, you might consider using load change property, but remember to not overuse it. They can be deadly if there are too many, or they are easily triggered, as I said. And there's a great page will tell you what is going to be triggering layout or paint, like which property is going to trigger which type of change. So this is a great resource to try. Then there is appending elements. What happens when we append or remove elements? The whole context down below from this element is going to be repainted or reflown, as you can see in this example. So if you don't have too many elements below, it's not going to be a real problem. But if you have like big news site, like big page, then it can really be harmful for the performance. Things can get laggy or jumpy. So what we do here, we should make sure that not many elements will get affected. We can, for example, separate the area using the wheel change to have another layer, or contain layout, which is unfortunately not supported really well yet. But if it is, and I'm really hoping it will be, the contain layout will make sure that this part of the page will not affect the rest of the page, and anything from outside of the elements won't affect anything inside it. So it's like really powerful tool. We can also make this areas height set and then put it on another layer. So we are using overflow property. We have scrollable area that will not affect other parts of the page. So this is something we can do about it. And then last but not least, there are images. They're not really interactions, but I've decided to put them in here because there are like so many things that can go wrong with images, and there are so many things we're doing wrong with images that I thought it might be worth trying. And I'm not going to talk about all the things that we can optimize when it comes to images, only 3 things. So we're going to talk about how they can be downloaded in very unexpected ways, how they can cause content jumps on load, and about how we sometimes optimize them incorrectly. So images downloads. So it turns out that semantics mark the performance when it comes to images. So if we have very important image, we should rather use image tag than the background tag. And if we have image that is highly only for decoration, we might want to use background image property. And this is because how image is embedded will actually influence when it's going to be downloaded. And Harry Roberts has an amazing article. He just went through all the browsers and how everything gets downloaded. So it's like super useful. So if we use image tag, it means that the images will start getting downloaded at the same time as CSS. So if images are really crucial for your website, if it's like image heavy like Tumblr or Unsplash or anything like that, it's probably a good idea to have them as image tag. But if your images are only for decoration and you put them into background image tag, then it means they will only get downloaded when they are found out in the CSS style sheet. So it will be a bit delayed, but the rest of the page might get laid out earlier. Also, if you have images that should show on the mobile screens but shouldn't show on the screens that are on the desktop screens, you should actually override the property, because otherwise they're going to be downloaded. So for example, if we have an icon for the hamburger menu, we should say background none for that on the desktop. Otherwise it gets downloaded. Image content jumps. Probably all of us have seen that. Like, we start reading some article that is still loading, but then some image pops up at the top of the page. Everything gets moved, and we don't know where we were reading the text. Fortunately, it's not happening in Chrome anymore since version 56 because of the scroll anchoring that is natively embedded there. In other browsers, it can be avoided, for example, using the placeholder content with the intrinsic ratio. So what we do here, we take image height and we divide it by image width that is multiplied by 100%. And then we apply this to the bottom padding of the container. We set heights of 0 and overflow hidden to this element. And inside this element, we actually put an image that is positioned absolutely. And we can, for example, have some, I don't know, placeholder image or some text that image is going to be downloaded or something like that. And then we don't have this content jumps in any browser. And optimization. When it comes to optimization, it's really tricky. So of course, the less images, it means better performance, because sometimes images can be the biggest part of our website. So if we can skip some, it's a great thing. You should always use the correct format. So the rule of thumb is, if you have, for example, a picture of something, picture of a cat, you should use probably a JPEG. If you have some graphic content, you might want to use PNG. And also, you should make sure that the optimization is the very last step in the pipeline. There's an amazing talk by Kornelski from Prettier CSS, so you should see it once it's released. So basically, if you, for example, have your image and you run it through a tool like Image Optin or Tiny PNG, and then you decide to cut off a few pixels, you should go through the optimizations again, because otherwise all the effort is ruined. So the takeaways from the talk. The junk happens when the browser doesn't finish rendering a frame on time and doesn't hit the refresh rate of our browser. You should try to offload and optimize the main thread. You should avoid content reflows and repaints, and you shouldn't overuse layers at the same time. You should always test your website with performance layers in the rendering tabs even before you start any optimizations, because sometimes premature optimizations can actually cause some harm. And you should be really careful with using potentially dangerous UI patterns. So here's the resources list. As I said, I'll share the slides later after the conference. I hope you'll find some of them useful. And thank you. Dziękuję.
Thank you very much.
Thank you. Let's have a short interview. Okay. Now, Anna, the first question is, I want to comment a statement. Performance is not a feature, it's a requirement. So what do you think about that?
Well, it definitely is for me, and it definitely is for a lot of developers, but sometimes it's the requirement that is easiest to swipe off the list of requirements for the client, because it's really easy to overlook that if the client is also using high-end devices. But we probably should find a way to convince the client that it is a requirement, because otherwise what will be the reason to create a page if it's not usable, even if it's the most beautiful part of the web?
Okay.
And my question is, Anna, so how can we remember all the things about browsers and internals? Maybe is there some tips from you?
I think it gets easier when you say the same tag for the 10th time, then you can remember all the browser internals. But there is a great, I think it's Udacity course. It's definitely listed on the list of resources. So after going through the course, it's like way easier to understand how it's working. Also, if you go to the developer tools in Chrome, it shows all the steps in the network tab. So you can actually look through that, and after some time, you'll probably start understanding it better.
Okay, thank you. Thank you a lot.